Yeah, I'm going to introduce the MITRA project, and the title of my presentation is Beyond Just Machine Translation for Pre-Modern Asian Low-Resource Languages. So because we have started with machine translation, but we are currently exploring different applications, and I will give an overview of the different outlets that we are covering. Let's see that this works. Yeah. So my presentation has three parts. In the first one, I will introduce our machine translation work. In the second one, I will show the MITRA semantic search, and it's a bit like Perplexity AI for humanities, one could say. So that's the second part. And then the third part, I will show our language model. It has a bit of a clunky Sanskrit name, but this is our underlying model that we use in order to fine-tune for the different applications that we support. So yeah, that's the three parts. Before I'm going to start with the individual parts, I would like to introduce our team, that you just get an idea of who is MITRA actually and who's involved. So on the one hand, there's Professor Kurt Kreutzer. He's known for efficiency, deep learning, and compression of models for many years. His group is mainly working on that. But he has also developed a strong interest in NLP tools over the last years and is leading this MITRA project. Then there's myself. I'm working on the technical implementation of the project, on the deep learning systems and training models and supervising that. And then we have David Alport. He's a data collector for Sanskrit. He's a permanent staff member in Berkeley. And then we have, outside of the US, Jivnesh Sandan, who's at IIT Dharwad at the moment, assistant professor. He has been working together with us on the training of Sanskrit language models. And then we are happy that we have two very motivated undergraduate students that work with us on different sub-projects. Yeah, so that's the core team, we can say. And then we also have collaborations for this project around the world. So this is a Buddhist monastery, Fo Guangshan. They are in Taiwan, and they are leading big translation projects for Buddhist Chinese into English for many decades. Actually, they are doing this, I think, for almost 100 years now. So on that end, we are super happy that they are helping us here. And then we have a big NGO in India, actually. It's called Mönlam AI. They are working on creating language applications for the Tibetan language, which is I think before we started, it was an extremely low resource language with only, I think, a few 10K sentence pairs at all. And now we are somewhere at 2 million. I will show more details on how we got there over time. But this is a huge group, and depending on what we are doing, the team is scaling up and scaling down again. So at some point, we had up to 400 people working in India on going into libraries, looking for books, scanning them, aligning sentence pairs, and so on. So this is really an amazing team that we could work with and hopefully continue to work with in the future. And then lastly, I would like to mention the Kumara Jiva project. So we have a number of professional translation projects in the larger sphere of Buddhist-related languages. The Kumara Jiva project came forward, and they proposed a close collaboration with us. So these are really, one could say, consumers of our tools, and they give us very close feedback, and we are very happy because it's actually quite difficult to find professional translators who also are willing to sacrifice some of their time to give close feedback on how such a system is working, but they have been supporting us on that end. Yeah, so from there, going to the machine translation part. So, I mean, for those of you who want to try it out, you can use this QR code. The URL is kind of simple. You can go to dharmamitra.org. And yeah, I can just show you a small video of how that translation system is performing. I guess there will be no big surprises here. You can enter a Sanskrit sentence in this case, then you can push the translate button, and we first generate a translation. And what we also do, this is something we recently added, is a grammatical analysis of this, because Sanskrit, I don't know, for those of you who know, and I will have some slides on that later, is a morphologically rich, complex language. And just spitting out a translation, especially for a pre-modern language, is usually not really what users want. They also want to have some additional explanations of how the individual words work, how that translation comes about. And this is why we have this explanation system here. And how that works in technical details, I will show that in a moment. Yeah, so that's the translation experience. Then we have grammatical analysis tools that are linked up with dictionaries. So you can actually, for a sentence like this in Sanskrit, that's another alternative. So what you have just seen is an LLM-based explanation, but this is like a a hard explanation in a sense. It goes through the parser, and then we link it up with dictionaries and resources that the users actually want to check if they are translating. Maybe there's some interesting meaning in a dictionary that they haven't seen yet. So that's where they can go in order to understand the individual parts of the sentence. So to recap that, the MITRA project, the main languages that we are focusing on is Sanskrit, Tibetan, Chinese, and Pali into English and other languages. Now, this choice is a bit hovering around the languages of the larger Buddhist culture sphere, because there are many other pre-modern languages in Asia, of course, that could also be included, but we are focusing on these because there's some interesting overlap on the corpus. Then we do grammatical explanations for Sanskrit. That is what I just demoed. We are currently the state of the art for Sanskrit, Tibetan, and Chinese to English machine translation. So at the current state of the project, we are focusing on translation into English, but we do actually have a lot of people requests from Korea, from Japan, from China, from Taiwan to also support, and Vietnam as well, to also support translation into their language. So we will hopefully get there at some point. We have between 600 and 1,000 daily users, so our system is focusing on academic users, on translators, humanities users. So the target user base is not very big, but we have almost 1,000 daily users. That is, I think, a nice thing. Yeah, to give a bit of an overview of the languages we are talking about. So maybe this maps helps a bit, because Sanskrit has developed in the Indian subcontinent, and then we have Tibetan on the plateau, and Chinese in the Chinese era. And this is, of course, a very difficult landscape to navigate, because all of these high mountains are difficult to pass. You have to get on, maybe have a group of camels, caravan, in order to pass over. It took many months actually to do this in the 1st or 2nd century. So this is really the difficulty of transmission, is also physical difficulty. At that time, it was extremely difficult to get people from China to India or from India to China. And yeah, so that's the background. Yeah, to say a bit about Sanskrit and Pali, for those of you who are not familiar with these languages. So there are classical Indo-European languages. Sanskrit was actually widely used as the lingua franca of the religious, scientific, and literary communities of ancient India, and this over 2,000 years almost. And if we include Vedic Sanskrit at the stage, we could even go back to maybe 1,500 before Common Era. So that's really, it's a language that has been active for a very long time. Pali is strongly related to Sanskrit, and the dating on that is a bit murky. Somewhere between the 4th and 1st century before Common Era is where the language appeared on the map. And both of these languages, they rely heavily on morphology. They have relatively free word order, complex verbal system, and a lot of nominal declension, and use compounding heavily. So all of these factors make NLP applications really challenging. And I think on Sanskrit, we are really lagging behind what you could do on Latin or English or other languages for many years already. So even just to do a full text search in Sanskrit is extremely difficult, because our actual information is buried under all of these factors that make it difficult. There's the unique challenge of Sandhi, which means that basically morphemes will merge together, and we also do this in writing, phonemes actually. So when we write Sanskrit, we write it the way we speak it. So we will have all of these meeting of words will create phonetic changes, which again, if we want to do a full text search on Sanskrit, we need to untangle that first in order to make it possible to get to the actual word. Yeah, this is just a picture of a manuscript of a Pali text. As an example, you can see there's no punctuation, nothing really that gives us a lot of visual clue on how to segment this text. Yeah, classical Chinese and classical Tibetan are very different. So these are Sino-Tibetan languages, and as you can imagine, the Himalaya separates them from India, and in that way also the language family is very, very different. So classical Chinese, it relies heavily on word position and context, and this, contrary to Sanskrit and Pali, uses almost no morphological markers. There's a strong emphasis on brevity, so whatever can be guessed from the context is usually also omitted. So that's part of the style in classical Chinese and in Tibetan as well, to be as concise as possible. Classical Tibetan, unlike classical Chinese, uses particles to indicate the case relationships, so that makes it a bit easier for NLP applications. And then one unique thing is, I will show a bit of statistics on how much translated literature there is, but even though classical Tibetan actually started as a language of translation from Sanskrit into Tibetan, there's almost no loan words and shared vocabulary between the two languages. So in a way, the Tibetans really sat down and mapped every Sanskrit word to an own word from their own language. And if you look at the written language, you see basically no connection. It's not like French and English where you can see how it has traveled, but it's really, it's very, very challenging. So just looking at the languages, you wouldn't get the idea that they're actually content-wise so closely related. The Buddhist translation project, this is actually a very remarkable achievement. So large amounts of Buddhist texts have been translated from Sanskrit and other Middle Indic languages. And this is an ongoing research field. We don't really know what languages played a role in the transmission of Buddhism. Sanskrit for sure, Pali for sure, but there are other Middle Indic dialects that have been used 1,500, 2,000 years ago, and we just don't know. Like we have some ideas, we have some evidence, but it's really an ongoing research question on what happened between India and China and Tibet in that transmission process, what languages were involved. Translation into Chinese started in the 1st and 2nd century Common Era, so that's almost 2,000 years ago now. And I think currently we can say roughly 150 megabytes of Chinese text have been translated from Indic languages. So that's actually a sizable corpus. I think it's a bit difficult to compare with other projects, but I would even say maybe this is one of the biggest translation projects of that time. Into classical Tibetan, we have about 300 megabytes of text that is based on Sanskrit. And yeah, I think likely this might be the biggest translation projects of that time. To give you some visual impression, if you want to know how Sanskrit in written form looks like, this is an interesting case. It's a bilingual manuscript. You see the Sanskrit on top, and then you see the Tibetan writing below that in the smaller letters. And as you can see already visually, that's very different, and that also gives a hint on how different the languages actually are. And it's a rare manuscript because here it was really written bilingually. So the scribe first put the Sanskrit and then followed by putting the Tibetan under that. But this is usually not the case. So this kind of data, we don't really have that. Yeah, please.
Is there any significance to the thread?
That's a good question. I don't remember. I think it's more like just as a calligraphy device, I think, just to make it a bit more beautiful. I don't think there was a clear reason why parts of this were in red. Yeah. Talking about machine translation performance. So what does state of the art mean here? So we have, here's our machine translation system going from Sanskrit into English, and we use BlueRT as our metric. We can't really use Comet for this because Comet requires annotated data with the source language as well, and we don't have the bandwidth to do that kind of annotation. So we have to stick with something that operates on the English directly, and BlueRT has been our to-go metric so far. It lines up quite well with human estimates. And as you can see, this is a selection of different domains of Sanskrit literature. We have selected text from each domain, manually selected actually. And this just gives you an overview of how the performance of our model is, but also compared to Claude, GPT-4, and so on. And MITRA is the blue one, which in most cases comes up slightly on top, but it also shows how similar the performance actually to other commercial LLMs is already. So I think just half a year ago, the gap was bigger, but in a way they are catching up quite quickly. The one outlier here is Google Translate, which is generally not doing very well. And the open source freely distributed models like Llama 3 and so on, we are not even including because they are falling off significantly. Like they can't really do much useful with this. So that's for Sanskrit. Then for Chinese, we are actually very happy that we have a group of PhD students at Temple University from the religious department who have been helping us to collect evaluation data, and they actually extracted sentences from 37 different texts across the entirety of this these corpus so that we get a as representative as possible data set for this. So this is a totally about 5,000 sentences. And here you can see MITRA comes out on top. I think one thing to note about this one is the translations down here are actually quite popular texts that float around the internet in many cases. So we have them on blog entries, people writing about Sanskrit literature. They will usually also cite parts of these texts. So this is not very secret knowledge. And I think the reason why we see good performance here for the large commercial language models is obviously because they are scraping the internet and they will likely have consumed this. So I think there's some case to be made to look at texts that have not been seen on the internet so far, but it's also a bit tricky because as soon as something is translated, it might also appear in some way somewhere. I think that's our observation so far. So here the focus was really to look at texts that have not been widely circulating, that are more obscure things we actually had to extract from PhD thesis, some notes, footnotes, and so on, really more obscure things. And I think here the advantage of MITRA over the other models is in some cases more pronounced. And yeah, you can see the stable performance across most of these texts with some ups and downs. And on average, yeah, MITRA is outperforming the other models for Chinese.
How different is from modern Chinese?
For modern Chinese, yeah. I mean, it's a very good question, and I think it's also very complex because classical Chinese, and especially for Buddhist texts, so there is the classical Chinese literature of China that has been going on for thousands of years. And then Buddhist texts, they came with their own language when they entered China. So in a way, this language that emerged when people translated Sanskrit into Chinese is sometimes called Buddhist hybrid Chinese. So it's not really Chinese in a way that people in China actually could understand it. And I think there's a big ongoing debate of could people at that time really read and understand these texts. And I think it's probably was not easy for people in China to really know what is going on. And yeah, so we don't really know what underlying dialects and language we're actually dealing with. Also Middle Chinese languages that might have influenced this. Yeah, there's a lot of difficulty in that. Yeah. Please. Yeah. Mm. Yes. I think that's actually very important. And we do have big problems with the separation of the two languages. So that's also one of the reasons we actually have a big user base in Korea, and our system works well in translating into modern Korean, but we are currently messing up translating into modern Chinese because of the inference that our classical Chinese is producing. So we have classical Chinese is quite dominant. I will show some graphs on our data distribution, but we don't really have a good body of modern Chinese. And our system really struggles to understand the instructions when we have Chinese data because it will switch back to classical all the time. And that's like, of course, not what we want if we want to translate into modern Chinese. Yeah, so yeah, the PhD students are helping us this, and we are trying to sample as evenly as possible across different subdomains and the time periods as well. So that's another thing. This corpus has a time span of 1,200 years. So some of these texts might be from the 2nd century and others might be from the 15th century, actually. So we have that huge variation in time that makes it additionally very, very difficult, basically, to have a good uniform machine translation solution. Yeah, the grammatical explanation for Sanskrit, I can quickly say a bit about this. So we have a digital corpus of Sanskrit that's an annotated tree bank, basically. That was a project I was previously involved in Germany. We annotated 600,000 sentences, and then we trained a byte level, individual character level Sanskrit NLP model for that. So we pre-train on a large corpus of Sanskrit data, and then we perform Sandhi and this compound segmentation, lemmatization, and morpho-syntactic tagging all jointly because yeah, this task is really difficult, and for anything information retrieval related for Sanskrit, we have to get this working before we can do other things. And I think this is really a big step for Sanskrit NLP because otherwise we would not be able to do search. And this system is currently, I think, the state of the art for Sanskrit grammatical analysis. And the error rate, we have done some comparison. We are roughly as good as one single human annotator. And what also plays in here is that because Sanskrit is so complex, there's also a lot of disagreement on how to do tree bank annotation for that. And different teams have their different approaches to that. So yeah, but this is for our system. We have a publication at EMNLP this year on that, if you want to take a look at that. Yeah. This is our feedback from the translators of the Kumara Jiva project. It's not very systematic, and I need to apologize from that. It's really just we did interviews, basically. We sat down and just had a 1-hour interview with each of them after they used the system for a couple of weeks, just to figure out how they are reacting to that. And the summary of that is, like, in the end, we ask, okay, from a scale of 1 to 10, is this helping you, or are you more annoyed and you better not touch this? And I think all of them agreed. We have 6 professional translators who participated, and all of them agreed that this is helpful. And some of them even agreed that this is actually very helpful, 3 of them. So, I mean, that's a bit from the human side here. And yeah, I don't know, any more questions about the machine translation part at this point? Please.
From your example right at the beginning, where the video demo you gave, I noticed it had some sort of annotations that got deleted. Was that part of the English explanation, or that's often like a big sort of engineering decision, is how to handle the bullet point. I mean, just kind of meaningless visual organization stuff.
Right. I think what you probably described, I don't know if I can pull that off quickly, but let me just skip here. You mean the fact that this is actually simplified?
Yeah, if you go to the top there, in the input, there was some sort of like list formatting. Like
this one,
the ABHT.
Yeah.
It's totally deleted on the target side.
I get your question now. Yeah, so this is basically because that is what we have here is noise. So this is part of the markup of our Sanskrit data. So the data input, this is basically an identifier that tells what verse from what text it is. And these identifiers are used a lot in Sanskrit digital text. And we trained our model in a way that it will omit these identifiers because they can cause problems for the translation process. So it was part of the objective to just ignore those. Yeah. Yeah, please.
Can you talk a bit about the writing systems for these languages?
Yeah, so I think Sanskrit, basically the Brahmi script was the first writing system. I think it should go back to the time of Ashoka, if I'm not mistaken. So, and basically all the Sanskrit writing systems for the manuscripts later, they were derived from Brahmi. So it's based on that. It's a syllable-based writing system. And Tibetan took a lot of inspiration from that. So they basically studied the Indian scripts, and then they created a script that follows many ideas of that. So it's also a syllable-based writing system, while Chinese, as we know, is completely different. Yeah. So Pali, I think it will also use different South Indian Brahmi-based scripts. I'm not really an expert on what they used for the manuscripts, but they will have used the Brahmi device script, I'm quite sure. Yeah.
And for the kind of data, are there sort of scholarly glosses or writing systems that researchers have invented for these, or did people already study text based on original?
So on that question, I think what we see is that different researchers, depending on nationality and background, have different preferences. So people educated in Western universities, they prefer to follow the Roman transliteration scheme that you also see here. So this is basically using IAST, which renders Sanskrit into Roman alphabet, which then for people who have studied Latin or Greek, it will look a bit more familiar and be easier to understand. While in India, of course, people will prefer Devanagari, even though Devanagari historically is not really the script of Sanskrit. Yeah, it's kind of what is used nowadays. It works well on Sanskrit, so you have those local preferences. People in Japan kind of tend to use IAST, the Roman transliteration, a bit more. Yeah, so you have kind of those differences. But for digital processing, Roman transliteration has been dominant for the last 20 years, but now I think with the rise of Unicode and most problems are solved, we can do Devanagari directly, actually.
I'm guessing though that the ISP and the Devanagari are like, one-to-one.
Yes.
You can go back and forth.
Yes. Yeah.
Good.
Yeah.
What do you call it? It's proper transcoding, nothing long.
It's lossless, yeah. That's the good news. Yeah, it's a bit different for Chinese because if we go between phonetic, like the transliteration into Roman and back to Chinese, we really have to be careful if we do that. Yeah, but for Sanskrit, the good news is, and the same goes for Tibetan, there's also a Roman transliteration system that is lossless. And that is what in research has been dominating because it was easier to handle until very recently, I think, with widespread of Unicode. And even for Tibetan, input methods for mobile phones and for computers are just catching up. It was quite difficult to do that just 5-6 years ago. And for mobile phones, it really just since, I think, 2 or 3 years that you have well-localized systems that can do Tibetan. Yeah?
Can you say a bit more about the difference between modern and classic, or this pre-modern, I'm not sure what term that 2,000 years ago Chinese? I'm just thinking, if you try to read English from 800 years ago, it's barely recognizable with effort.
Right.
So is the drift? I can see reasons why the drift might be less for Chinese, given the preference for brevity and the ideographic writing. But I don't know what you can say to how it's sort of surprising that a system built for one can, or that it can translate, across a range that.
Yeah, I think one of the really amazing things of the Chinese writing systems with the characters is that there's a lot of stability of the use of characters, even over a time of like 2,000 years. So I'm not a sinologist, so I can't really say this with full confidence, but I'm very sure that most of the characters that have been used 2,000 years ago are still in use today. But their meaning is changing extremely depending on the context. And if you open any like a proper philological Chinese dictionary, you will get for each character a list of 50, 60, 100 meanings. And that is because the context is so extremely important. And the same character can be read totally different, the pronunciation can be totally different, and the meaning can be totally different. And it's a bit deceiving because you think you know the characters, but it can be actually extremely challenging to understand the meaning of the sentences. Yeah.
So relative to English, is the drift a lot greater? Is there any sense in the question?
Yeah. So I would assume the drift of the spoken language is so strong that you would not be able to understand somebody who lived 1,500 years ago during the Tang dynasty or something. That would be impossible, I think. There's some evidence on that. We have some like phonetic transcriptions from that time, and that's totally different. I think from reading, it depends. I think a well-educated Chinese person might well be able to read a bit of Tang Dynasty literature, but whether it really is full understanding, that's a different question, I think. In a way, the written language doesn't look as different as Old English. Yeah, I think we see it and we can't even figure out what the words mean. I think that's different for Chinese. You can make your way, but it gets very tricky. It can be then definitely very challenging. Please, yeah.
How can I use or that kind of the article to handle the part? I'm curious, how do you tokenize it, or how do you do the math of it?
Yeah, that's also good. And I think the good news is that the general open source model, so we are currently building on Gemma 2, I might show that a slide later, they are actually catching up with proper tokenizers that support these languages. So Devanagari is quite well supported by Gemma 2, and the tokenizer efficiency on Sanskrit is okay. I wouldn't say it's amazing, but it's okay. So we are kind of getting there. For Tibetan, just this year, basically, the first language models, the large open source ones, Gemma 2 supports it. I think Llama 3 does not. Hopefully, the next Llama generation will support that. So we are seeing these are really, they're added by the months, you can see. And I think that's also Claude probably does support Tibetan script quite well right now, but it didn't do that just 1 year ago. I think the older generation did not. And for Chinese, we fortunately don't have this problem. So on the processing side, Chinese is a very nice language in many ways because the characters have a strong meaning and they're easily separable and so on. So a lot of problems we have for Sanskrit are fortunately not applying for Chinese. And tokenization is certainly one of that. Yeah. Okay, any other question at this point? Then I might just move on to the information retrieval part. So yeah, semantic search. I mean, first, for those of you who are not really, don't have a good idea of what the field is actually doing. So in philology and the research of these original documents and literature, actually the translation part is the smaller part. It's more like a byproduct of working on this material. But in research on Indian texts, on Tibetan texts, and to some extent on Chinese texts, establishing the text is really the most important part. And why is that the case? Because the transmission of this material in South Asia is extremely difficult. So we have problems like climate, the humidity. The manuscripts are written on palm leaves, and those palm leaves, after some couple of years, they will just start to rot, and there's not much you can do about that. Insects will come, they will eat holes into that, they will take away a word here and there, and then you have those problems. And this is why actually there are professional scribes who sit down, and every 50 years they will copy those manuscripts. So if we have a surviving Sanskrit text nowadays, we can assume that it was probably copied 50 to 100 times, something like that. So that is what happens. There are some positive exceptions, like Dunhuang, for example. There's a cave in China where a lot of those manuscripts ended up. They have been preserved in the dry desert climate very well. So, and these are the great findings. If something like that shows up, that is a wonderful thing. And also in Tibet, actually, in Nepal, Tibet, the climate is more friendly towards manuscripts because it's drier, it's up the mountain, and there's not that much degradation. But generally speaking, the climate is a big challenge. And as you can imagine, if you have to copy a text every couple of years, this will cause a lot of mistakes that creep into the text by the scribes that do the copying.
Please. A whole lot better though than a few thousand years before that.
Yeah.
And the only way you transmit it by memorizing and reciting it.
Yes. I think that's actually something somebody might debate on this. I think the abilities of in the Vedic times, so even before Sanskrit started to be written down, memorization was the only way to transmit this. And people would, there was a strong curriculum of students already at the age of, I don't know, 3 or 4, I don't remember, but very, very young. They will start to memorize Vedic text, long, like hundreds, thousands of verses, will memorize those and will then be able to recite them on the level of syllable precision. And in a way, I think that led to a quite stable transmission of the core text of the Vedic tradition into modern times, because that process, at least if you learn it very early, has a very high reliability. It doesn't work so well for people who start to memorize when they are grown up. That's the downside of that. Yeah. Okay. Yeah, so in a way, I think this is an ongoing debate whether the written transmission really is more reliable than the oral one. They have their ups and downs, but certainly you need a lot of experts to do the oral transmission, that's for sure. In a way, I mean, I might call this a bit of a gap token prediction problem. If we have manuscripts with holes in them, in a way, it's a bit like, okay, like a language model will predict that hole. And of course, philologists would not like this description. But in a way, they are probably human language models by the end of the day. But of course, a good philologist will make use of all possible evidence. There might be other manuscripts you can use. You might see some evidence on what kind of errors have been in the actual manuscript. So that is all things that I think multimodal models could be very fascinating to explore on how to not just do translation, but to do those philological tasks as well. And then one of the important parts why this whole project is focusing not just on Sanskrit, but Tibetan, Chinese as well, is because parallel versions transmitted in other languages are vital for this. So we might have a Tibetan translation of a Sanskrit text, and when we have a hole in the manuscript, we can say, okay, the Tibetan might help us. And that's where the whole big research question around this parallel corpus of Buddhist literature across these languages really comes into play, because we want to know how have these texts developed, what is the common core across Tibet, China, and India, because only in that way we can really get to better ideas on how earlier versions of the text might have looked like by comparing them. This is just one example of one of those manuscripts that has been badly damaged. It's one I worked on previously in Germany. It's actually beautifully written from the point of view of handwriting and style. This is a very, very nice example. But unfortunately, 1/3 of that got burned on one side. There was a fire in the monastery and they kind of tried to save it, but yeah, didn't fully work out. So this is one of the typical examples that people will work on when doing Sanskrit philology. And yeah, that was also the driving research question for me to get into computer science by the end of the day, because I had the task to reconstruct those gaps. And a friend of mine was doing computer science already in Germany at that time, and he told me, why don't you just train a language model and reconstruct that? It looks a bit painful what you are doing. And actually, it just took me 6 years of computer science to get to the point where I can say, okay, let's train that language model. I wouldn't say it's working very well yet, but we are doing one step at a time. Yeah, so I'm not sure if I would have just stick to doing that manually. Maybe I would have gotten there quicker. I don't know. At this one, you mean that this one, yeah? Yeah. This is a so-called string hole, because when you have palm leaf manuscripts, you would actually put a hole in the middle in order to stack them. You can put a string through them, and then you make sure that they actually stay in order. It's a big problem, and especially with this manuscript, they totally messed up the order. I think somebody just removed the string and then they throw it around, and then you have this shuffled deck of things, and it's very difficult to even know where you should look at. Yeah. Mm-hmm. Yeah. So what is our solution to these general philological problems? So we have our own, some people call it perplexity for Buddhist studies. It's a semantic search system. We have a simple interface. That's how it looks like when you go to that interface the first time. And then you can enter your query in English or other languages, and then you will get results from all the different languages. And this is for somebody who is working on a Sanskrit text, and they might have something like, they want to check this sentence here in Sanskrit, and then they want to know how is the Tibetan, the Chinese version of that, in order to get to an idea of what maybe the meaning is at that point. So that is the research question we are addressing with this. So you can do multilingual retrieval, because it is a huge pain to study these languages. Like, to get up to speed in Sanskrit, to be able to do philological work, takes 5 to 10 years. For Tibetan and Chinese, that's roughly the same. So if you do all of these properly, you are sitting there for 20 years just learning languages. And then you can start to do this reconstruction work. And I think this is really where AI tools can become a great help, because it's not always needed to understand this brilliantly to all details, but just to know what is going on in the parallel version will be a great help for the people. Yeah, this is a live demo of our system. So people can enter whatever query they have. We support queries in English, so you can also look for some topic in English. And once that is typed in, you can click on search, and takes a small moment. And then we have the results. Actually, we present them first in the primary language. So in this case, it's Tibetan. And then we have the optional step of explanation, which is a cross-lingual summarization of the results. So we have a language model trained that will take the Tibetan and then translate and summarize it at the same time. And it will also do a bit of explanation of how that result matches the query. So if I'm asking a question, don't know, what did the Buddha say about eating meat? And then if you get the result, then it will say, well, this passage discusses the topic of eating meat from that point of view. And then you get all of those explanations together with the translation. One thing here is really about, yeah, I can go through the different parts one by one. So we have that search input. We support English, Sanskrit, Tibetan, Japanese, Korean, so the major languages that people will use nowadays in order to do research on this text, as well as the classical languages. Then we have filter options. This is important because our users usually know very well what they roughly want to search for. So they have a good idea of the material. They know the corpus, they know the text, they know the authors, but they just don't have the time to read all of that. So they know specifically where they want to look at. So those filters are coming in very, very handy. And then we present the result in the original language first. And this is so important because our users don't trust LLMs. That's my lesson that I learned over the last year. They don't really like the technology, and they will say, well, that's hallucination, and half of the stuff that comes out of this is wrong. And I don't want my students to use LLMs that will just create big problems. And of course, we get the same kind of criticism as a project. They're like, okay, now you are bringing LLMs into philology. That is not a good idea. So that is feedback that we got quite frequently. And our way to deal with that is to actually put the source always as first and to really lead the people to the original source text and not say we are just serving I mean, we could also build a WAG system, yeah, where we have just English summary of these results and we just say, okay, well, here's your perplexity, you got it now. But that would invite more criticism because there's more possible hallucination and distortion. I mean, as much as I like perplexity, but I mean, we know that it sometimes mixes up two websites into one answer and it's not always working seamlessly. And for a system like this could be crucial because if that happens, just one or two people not liking the system in a research community of maybe 1,000 people worldwide can have a big negative impact. So we want to make sure that the system is really helpful. And that's why we emphasize the original language first. And the summaries are really something they have to press the button for that. So it's a bit like their own decision to see that or not, even though I think it's actually used quite frequently. I don't know, any questions to this search interface at this point or? Yeah, thank you, sir. So we are currently in an alpha state. Maybe we are moving from alpha to beta, and we hope that we can make it public by the end of this year. But I don't know, for those of you who work on information retrieval systems, it's quite nice to get a working demo that does some examples very well. But if you only miss 10% of what the user might be looking for, you are in deep trouble. And we are currently maybe at still 5% remaining where we know, okay, if we fix that, then we can finally release it. So I hope I'm not too optimistic if I say end of this year, but we are really reading out those remaining results where people say, well, that should have been there. Yeah, that's not coming out. And that's really the challenge that we have at the moment. Just to give an overview of the layout on the technical end, I think this might look not very surprising. We have a search query that could be anything Buddhist related. In this case, what are the Four Noble Truths? A very general question. Then we have a first optional step of machine translation. So when the query is not in English, we need to make sure that it is in English. But we also feed our query directly into the search system. So if it is in Sanskrit or Tibetan, we also have semantic embeddings in Sanskrit and Tibetan. So we have native models, but we also have semantic embedding models on the machine translation. And we really combine all of this. So this is a bit like a fisher uses different nets in order to catch fish. And we are having kind of 6 or 7 different nets in the water here, basically. And here it's only 3 of them are shown, but we are really experimenting with what can we add in order to have more meaningful results here. Then we have a re-ranking and filtering step here. We have our own custom filtering model that ranks the results according to relevance. And then we have our results. That's basically the list of primary sources. And then we have the optional step of translation and summarization at the end. So that's like the schematic overview of this. Yeah, any questions about the information retrieval application? Anything else? Please, yeah.
The whole architecture you built here, there must be some literature on this as well. I mean, people apply this to, it seems like you can apply it to Greek philosophical texts or the Torah or the Christian Bible or something as well.
Yeah.
Has it been done in those areas, or is this something that you came up with just for this? I just don't know the literature pretty well in this area.
I know of one team in Germany who have done this for medieval German texts. And they have also created a specific fine-tuning corpus for that. But I'm not really aware of other teams who do this for this specific humanities classical language approach. Of course, there's perplexity and lots of papers on information retrieval in general, but I'm not really aware of people who need to go to that extent of machine translation and so on in order to get all of this working. So yeah, I mean, I'm super interested if somebody here knows more about that, has some idea of other people doing that. I'm happy to hear. I'm quite sure there must be teams that are working on this. I don't know how many got to publish yet.
Okay, yeah, I guess I'm not thinking of the MT. Most people are just searching for things in their own language, searching over translation.
Yeah. Right. I mean, the problem is also in order to have a good semantic embedding model for Sanskrit, for Tibetan that works natively, so to speak, with Tibetan input and output, what data do you train on? Yeah, do you have annotators that can create that semantic similarity examples? And in our case, actually mining through the English machine translation has been most effective. So we translate our whole corpus into English, and then we use a good embedding model on English in order to mine Tibetan to Tibetan and Tibetan to Chinese sentence pairs. And I will show a bit more of that also later.
Do you have any sense here of how important it is to translate the query versus just searching over translations of the texts?
I mean, the query is important because if we search over the translations of the text and the query is not in English, in the translation language, we have to do something, yeah, because we can't search for Japanese directly in English. I mean, we could try with a multilingual embedding model, but it is more stable to have an English embedding model at this time. So the input needs to be English in order to match that. Yeah? Mm.
And an overall question about the nature of MT and IR and search in this context, which is that you're dealing with a relatively static collection, meaning your collection is not going to change. There aren't going to be any OVs that you hadn't seen before, and
maybe every year 2 or 3 manuscripts are added. So there's a bit of that.
Whether this is somehow qualitatively different for MT, for example, or for even IR for search,
yeah,
what we typically deal with.
I think so. I do think so. I mean, this whole fact that this is a closed world, it has been done, so to speak, even though I think there's also the aspect, the ongoing process of digitization. Like we only have maybe 1 to 5% of Sanskrit literature available here. So in a way, it's a closed world, but we don't know how big it is. And I really hope we can add more data constantly. So in a way, I mean, for Tibetan, that's a bit more settled because the data is more available. The monasteries have been more productive in making that available. But yeah, it's somewhere in between, I would say.
And also in the same way, the nature of what people search for, some of the examples you mentioned sounded like what IR people would call known item retrieval. You kind of know in your mind what you're looking for. You're reasonably sure it exists. And you're trying to formulate a query to get to that.
Yeah.
So what else do people do with this? Are they, this reminds me, for example, of another collection of Holocaust survivor interviews. And again, it's a closed collection.
Yeah.
And people typically are looking for a few different things. Some people are just looking for the relatives.
Yeah.
Others are looking for some historical aspect of something or the other, the historians. Others are looking for stories that they can use to tell in classrooms.
Yeah.
What kind of things do people look for over here?
So I think in the stage we are currently at of this project, the people who use this have a strong research background. They know their text. They know the languages in general. Like I wouldn't advise people who don't know Sanskrit or Chinese well to really use this because the machine translation is kind of, I mean, we are getting better, but it's still not at the stage that I would recommend anybody to use this without being able to check if it's really, really good. But those people, they know their content. They have very specific ideas, what you just mentioned. You know, that when did that person meet that other person? I know it happened somewhere, but I forgot the text. I read that 10 years ago. How can I get there? Or I'm currently working on this Tibetan manuscript and they're talking about a certain deity, but I totally forgot if this was ever mentioned in Sanskrit. Let me quickly check that. So, and usually if you do that by hand, you are spending weeks and weeks of reading through literature and text in order to have an idea, was that deity ever mentioned? But with this system, you can be quite quickly coming to a conclusion. And that's the kind of use case we are targeting at the moment. I mean, hopefully at some point, if we can get more abstract, we might also be able to have more general Q&A capabilities that might also go into what just lay practitioners of Buddhism, for example, might be interested in. People who have a general interest in Indian history, they might just want to read want to know, did the Bhagavad Gita ever talk about, you know, certain topics? And that I think hopefully we will get the ability to be more abstract. But right now, it's really much closer to what researchers already have on their mind, what is closely mentioned in the text. Yeah. Okay, maybe then I will move on to the LLM part of our model that we are using here. So this is the layout of our training data. So we have a total training corpus size of 5.7 gigabyte. I think this is roughly 7 billion tokens in the tokenizer of the Gemma 2 model that we are using. As you can see, the largest part of this cake is English. And this was largely collected by downloading everything from archive.org that has Sanskrit or Buddhism or Tibetan in the metadata, basically. We just scraped all of that. And then we had a Google grant in order to get that data into OCR. And then Tibetan and Chinese, these are traditional collections of Buddhist scriptures and treatises. They are already digitized by monasteries and so on. So on this part, we didn't have to do too much. These are the monolingual corpora. And for Sanskrit and Pali, we had to do a lot of data collection ourselves from PDFs, from things that are available. There's a bit of digitized Sanskrit text scattered around the internet. Certain universities have their own collections, and most of this is available in public domain. But we had to make some effort to collect that and bring it into one place. And then we also have a slice here, the parallel data, which I will explain in a moment. So we did a bit of data cleaning, strip away markup information, and then we also removed lines where less than 50% were matching n-grams from our major languages, just to get the most noisy stuff out of this. We also did fuzzy deduplication on full text basis, because in this data set, certain texts are present 50 to 100 times, like the Bhagavad Gita, famous Sanskrit text, is spread out through the corpus many, many times. So we have an over-representation of those, and then we have under-representation of a lot of other texts. So for this, we used deduplication in a fuzzy manner, but also the text boundaries were not good. So we had like these collected volumes, like one PDF can contain 50 texts. So you actually need to deduplicate within those volumes. So it's a bit of a more complex problem. So we use some combination of fast text and local alignment in order to spot those embedded texts and remove them. We do have about 8 gigabytes of OCR, but not yet really clean Sanskrit data, and 22 gigabytes of Tibetan that we are working on. So that's what we can scale up to if we want to really be good at doing native tasks in Sanskrit and Tibetan. There's a lot that we can do. At the moment, goes a bit beyond our scope. The bit about the continuous pre-training details of the model. So we are building based on Gemma 2, 9 billion parameters. Maximum length, 1024 tokens. We might try longer windows. I'm not sure, maybe that helps. We have 2 million tokens per gradient step as a batch size. We trained for 2 epochs, and actually I think we could even go further. So that's a bit of a question there, how much we can gain. Maybe 4 epochs could still bring some improvements. We have trained on 8 A100s. 1 epoch takes 2 weeks, and the whole thing, 2 epochs, is about 1 month of training time. To say a little bit about our approach. So we tried this ALMA approach of just training on monolingual data and then use a handful of parallel data in order to induce the translation capability. We tried this on our data. It totally doesn't work. And I think that's an interesting observation that we made, because my assumption is that probably the latent knowledge on modern languages and translation in this big web scrape corpora is so big that ALMA kind of draws on abilities that the language model already has. But we are putting a really unknown corpus here of material that is extremely challenging to translate. And then we see, okay, this is really not converging. We tried this hard, but it's just not getting there. What works better is the Tower recipe from the Tower paper, which basically means we combine parallel data and monolingual data in one joint continuous pre-training step. We do that for 7-8 billion tokens, and then at some point we stop and we do a fine-tuning on instruction data that is really tailored to the problems that we are working on. So that was the recipe that gave better results. We have done different openly available LLMs. Llama 3, we did quite some work on that. The tokenizer is not that great, and generally it has not as good base performance. So Gemma 2 is really a better choice for these languages. We did work previously with No Language Left Behind. That was our model in about a year ago. And then we switched to MATLAB 400 in March 2024. And then from that, we went to in August, we went to Gemma 2. And what does this improve in quality mean? So this is for Tibetan. We have an evaluation data set. This is unfortunately still in CHRF. I couldn't yet crunch numbers on Blue-RT. But as you can see, this shows the performance increase that we have going from NLB, that was our model in October 2023, then to MATLAB, and then from there to Gemma. There's also a bit of additional training data we got over the time. So this difference in performance is not solely due to the model performance, but it's also because our training corpus, we got some additional data, but the difference is not huge. So we had 1.5 million sentence pairs at this point, and then we got 1.8 for MATLAB, and right now with Gemma 2, we are at 2 million. So I think it also shows that Gemma 2 is just really a good base model for Tibetan to English machine translation. Yeah, to English training data. So this is just to summarize on what we have done over this, I think right now, 1.5 years. So basically we started out with less than 100K sentence pairs for each language direction. That was our base corpus that was available in 2022. And then with the help of the NGO of Mönlam, we bootstrapped a semantic similarity model by just training on these sentence pairs that we had. And then we could use back-align in order to, together with the volunteers and the workers of the NGO in India, to collect text and align them on sentence level. So that is then what we did. And we basically managed within 1.5 years to go from 100,000 sentence pairs on Tibetan to English to 2 million now. So it's kind of a change from a low resource language to a maybe mid-resource language, which is amazing, I think. And the same for Sanskrit. We started out with, I think, 80K sentence pairs, and we are now at 1 million. So, and for Pali, the whole corpus size is just not that big. I mean, even if we would collect everything, we might have another 100K. So we have already about 60–70% of that data in our data set. And for Chinese, we do have 240,000 of Buddhist domain-specific Chinese, but then there are millions of sentence pairs of the larger Chinese domain, which kind of contribute to the system here as well. So now coming to the last data part is the parallel data for other target languages. So this is a very exciting thing to come back to the philological part, that we actually also collected data from Sanskrit to Tibetan, Sanskrit to Chinese, and Chinese to Tibetan. And yeah, I mean, we touched upon this before, so I might skip this slide. But the alignment problem here is really difficult because these texts have been transmitted over many centuries and they have developed independently from each other. So the Sanskrit text might have seen further changes after it was translated into Chinese. So this is not what you might have if you work on Europal, for example, where you have those professionally translated parallel sentences and you can basically use a length-based aligner to get a almost perfect translation corpus. That's a very nice situation. For us, it's much more difficult, but there's a kind of Europal hidden in this data. And I think it might be 1 million sentence pairs for each of the language directions that we have if we do a serious effort. And yeah, our automatic approach here gets us halfway there. So that's really, really a cool thing. And yeah, I think it will be very, very important for research. Yeah, the document alignment is also very messy. So what we have is that often only fragments of documents really match up. They are scattered in different texts. There's a section here, a section there, but really a text that is nicely translated and available in multiple languages, they are rare and difficult to find. Most of the time, it's much more complicated. Then we have the problem of sentence boundaries. That's a huge problem because if we want to compare two sentences, we first need to make sure that the unit is the same. Yeah, and if the one sentence runs much longer than the other one, and if you have languages that don't use punctuation, you will get that problem all the time. Yeah, so this is a big, big challenge that we have. And for that reason, margin-based mining doesn't work well. So you can't just say, okay, let's globally mine for sentence pairs. We have our embedding model. We can just do that. That's an obvious suggestion that we got at some point, but this is just not working. Like the quality of the data we extract that way is so low that you cannot train a language model on that. And I think also for research, it's not very interesting. What actually works is we first fetch candidate segments. So it's kind of chains of continuous matching sentences. So we look for similar sentences globally. And if there's a chain of sentences that match 20, 30 sentences, then we can say, okay, that's a candidate space that we will explore. And then we retrieve those chains, and then we do local sentence alignment, basically on that one. And if that matches certain criteria about minimum length, minimum cosine distance, then we can be happy and say, okay, great, that worked. So in that way, we first extract candidates of documents, which is fuzzy, and we don't know where the boundary starts or ends, but we do that first, and then we do a sentence alignment on that. And in that way, without expert annotators, we can extract the largest part of that hidden bilingual corpus or multilingual corpus of these languages here.
What about the metadata? In this task, I would think you might want to rely on.
Mm-hmm. Yeah.
To bring you candidates.
I think in the earlier stages of the project, we made use of metadata, but at some point you really want to have a universal solution, because the metadata is also not very complete. It's not really like people have put a lot of work of, I mean, there might be catalogs, but they are not matching up with the digital data. So we don't know how the file should actually be called and so on. And then all those problems come into play. Yeah? Okay, maybe at the very last part of my presentation, I will just quickly show the instruction fine-tuning data set. So we have done our pre-training, we have gotten all of this language knowledge into our system, and then we fine-tune on specific instructions. And we have about 60,000 of these. This is the overview. And yeah, the tasks are, for example, translation and explanation, what we have seen in the beginning of the presentation, then document level machine translation, where we take full pages and translate them at once. Then KNN translation. This is a specific request by translation projects. They want the system to stick to a specific vocabulary and style that they have used before. So including existing examples to guide the translation is an important capability. Then we have cross-lingual summarization for the search system that translates and summarizes at once. And then lastly, we have cross-lingual term extraction. So you have a term in Sanskrit, and you want to get the corresponding Tibetan term from a longer paragraph of text. So in order to extract that, we also have this as a separate task. Yeah, for those of you who want to download this, it's on Hugging Face soon. And hopefully the website, the search system will also be available. At least the translation system is online now. And yeah, I think that's it for my presentation at this point. Yeah. Yeah, please.
I'm instructed those are pretty big bytext that you were using. Those accounts were in aligned sentences, right?
Yeah, you mean this one? Wait, oh, one moment.
Yeah.
Yeah. This one or the previous one? This one. Yeah.
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 Both. I just was wondering if some of the techniques that you use to gather these, if you think they could be applied to other ancient languages as well, or is this kind of a unique circumstance just because there's sort of this richness of Buddhist texts that are translated to specific language?
So I actually think that the mining strategy we used in order to get this data could be interesting for other use cases as well, because it makes basically possible if you have an unknown corpus of language A with messy documents and an unknown corpus in language B with messy documents, that you can kind of automatically, without needing to identify document pairs, still extract most of this under the assumption that there are document pairs in that. Yeah, if you don't have document pairs at all, if it's only sentence, then it becomes difficult. But if you know there are document pairs, but you don't know where they start, where they end, and so on, then you can actually use this method. I think it should be quite universal. Yeah. Mm-hmm.
Do you have any problem that you think would make an interesting shared task to get other people interested?
I would be super happy to do that, actually. I think these are problems kind of, working on Latin, Arabic, and those languages. Probably there will be overlap and for other low resource languages as well. So yeah, we are very happy to look at a shared task that might work. Yeah.
One sort of off the wall comment. Many years ago, I used to work with somebody from UMass who was also looking at historical documents and images.
Yeah.
And he also had some techniques for doing search. But in his case, instead of doing OCR and things like that, which is often quite hard, he was trying to find representations of the document image. He didn't have to scan lines and things like that, and he was going to map those directly into a representation. So have you looked at that? Is anybody doing that? Is there any advantage to it? Because OCR on these documents is pretty hard.
Pretty hard, yeah. I mean, we do have that problem on the table because we have big manuscript collections in libraries where we really only have a photo of basically what I showed before, this palm leaf. We only have these photos, but we don't have any information on this. We don't even know what text it is. And I think a model that could at least give us a rough description, this page is talking about that topic, that deity, something like that could already go a very long way. And I think, going directly from the image into such a representation that makes this kind of queries possible would be extremely interesting.
Because the guy I'm thinking about, he left Amherst and went off to Amazon.
Okay.
But others...
I see. Yeah, absolutely.
Okay, let's speak again.